So welcome back, guys. So what we're going to look at in this lesson is we're going to look at water, and we're specifically going to look at water hardness. So our learning intentions are to discuss the hardness in water, including causes of temporary and permanent hardness, and to explain the process of deionization. So the first thing I suppose is important to look at is to revise over some things you would have learned about water at junior cycle. So first of all, water freezes at 0 degrees. It's an excellent solvent. It boils at 100 degrees. It expands on freezing. It turns cobalt chloride paper from blue to pink. And it turns anhydrous copper sulfate, which means dry copper sulfate, from white to blue. So if we look at water hardness, from junior cert you'll remember that hard water is water that does not form a lather easily with soap. We build on this at leaving cert and we say this hardness is caused by calcium and magnesium ions that are dissolved in the water. The most common source of calcium ions in water is calcium hydrogen carbonate, and you can see the formula just here. And hardness in water, it can be temporary or permanent. So, temporary hardness is hardness in water that is formed from a reaction between limestone and carbonic acid in rainwater. So we can see that the carbonic acid from the rainwater reacts with the calcium carbonate in the limestone, and it produces our calcium hydrogen carbonate, and this is what causes temporary hardness in our water. So, temporary hardness is hardness in water that can be removed by boiling it. So, hydrogen carbonate decomposes when they are heated. The calcium ions that are dissolved in the water are precipitated out to form insoluble calcium carbonate, which is commonly known as lime in kettles. And we can show this decomposition along here, saying calcium hydrogen carbonate, your chemical formula here, decomposes into calcium carbonate, water, and carbon dioxide. So we can test for this by adding dilute hydrochloric acid, and this will cause carbon dioxide to be given off, which will turn lime water milky. So if we look at permanent hardness is hardness that cannot be removed by boiling. It is mainly due to dissolved calcium sulfate, and sulfates do not decompose when they are heated. Permanent hardness can be removed in multiple ways. The first way is by distillation, and you'll remember distillation from junior cert and also from other sections of the chemistry course. Distillation removes all dissolved solids as the pure water is evaporated and then it's condensed in your Liebig condenser. However, this is very expensive on a large scale, so it's not commonly used. The second way permanent hardness can be removed is using washing soda or washing powder. Washing soda is simply hydrated sodium carbonate, and the carbonate ions in our washing soda can react with the calcium ions in the water and remove them as insoluble calcium carbonate. And if you remember, calcium carbonate is commonly known as limescale. The third way permanent hardness can be removed from water is using something called an ion exchange resin. An ion exchange resin involves swapping ions in a solution. It is used in both water softeners, both at home and in the lab. So softening of water at home involves the use of a cation exchange resin. So in the cation exchange resin, the resin exchanges positive ions. So these positive ions will be calcium and magnesium. And these basically get replaced with other positive ions that don't cause hardness in the water. So each calcium would need to be replaced by 2 sodiums. So the charge on your calcium is +2 and the charge on your sodium is +1. So you would need 2 of the sodiums, 2 of these +1s, in order to balance out your +2 charge. So eventually the resin will lose all of its sodium ions and it'll need to be replenished. And to replenish the resin, you simply pass concentrated sodium chloride through it. So softening of water in the lab is a little bit more complicated because it uses both the cation and the anion exchange resin, because we want to produce something called distilled water in the lab. So the cation exchange resin removes the positive ions and the anion exchange resin removes the negative ions. So let's say we have water and it has sodium ions in it and chloride ions in it, and we want to get rid of them. So the cation exchange resin will remove the sodium ion because it's Na+, and the cation exchange resin removes positive ions. And what it will do is it will replace that sodium ion with a hydrogen ion. Similarly, the anion exchange resin will remove the chloride ion, because we know the anion exchange resin removes negative ions. And it will replace this chloride ion with hydroxide ions. And basically, these excess hydroxide ions and hydrogen ions bond together to form water. So what we simply have is, we have the Na plus being gotten rid of, and we put in H plus, and we have the Cl minus been gotten rid of, and that is replaced by the OH minus, and the H plus and the OH minus ions bond to form water. So they come together to form H2O. So this slide here is quite important as it's a previous exam question. What is the difference between distilled and deionized water? So distilled water has removed all of the impurities, so dissolved solids, liquids and gases, where deionized water still contains dissolved gases. So that's it for this video. Make sure to have a look at the learning intentions to make sure you understand everything from this video.